Hello, welcome to 13 Universal Learning Beyond Barriers. You're welcome. We're starting full topical, full topic questions. We're solving questions, of different topics. All right, the way it appears in the exam. This is schedule. So come with me. Let's start. Remember, we'll solve this question with you. Okay. Now let's go to this is A level CIE biology. So we are starting all topics series 1. So let's do the first one. So you can pause the video and try this question. So which feature is visible with a light microscope using natural light source? Which feature? Okay. DNA molecule of diameter 2 nanometers. Paramecium cell of diameter 200 micrometers. Phospholipid bilayer of weight 8 nanometers. Ribosome of diameter 20 nanometers. Pause this video and check and then solve the question. What is the answer? What is the answer? Okay, now they said which, if you check this, guys, stay with us, right? Watch. They said which feature is visible with light microscope. Remember that the resolution of light microscope is 200 nanometers. Okay, you can only see from 200 and above. Do you understand? You cannot see any structure whose size is below 200. That is how it works. Because if the size of a structure is below 200 nanometers, that means it is too small to intercept or interfere with light radiation. So you can't see this one. Okay, remember, you cannot see this one. So look at it. So this is 2 nanometers. Okay, this is 8 nanometers. This is 20 nanometers. So you can only see, all right, a bigger structure, okay, which is 200 micrometers. Because if you start converting, remember that the resolution is 200 nanometers. So of course this is 2 nanometers, which is smaller. 8 nanometers is smaller. 20 nanometers is smaller than 200 nanometers, but 200 micrometers is bigger, okay, than 200 nanometers. So we can see this. Okay, so the answer is B. Right, let's go to the next question. It says the electron micrograph shows a structure found in cytoplasm of an animal cell. All right, that's the structure. So which biological molecules are found in this structure? Nucleic acids, proteins, phospholipids. Is it A or B or C or D? So pause the video and try. Okay, so the question is, what structure is this? Can you see? This structure here, okay, is central. It's made up of triplets of microtubules. Let's count it at 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 triplets of microtubules. Okay, so central is made up of microtubules. Microtubules are made up of proteins called tubulin. Tubulin are here. So it doesn't have nucleic acid, it doesn't have phospholipid, it has only proteins. So the answer is 2. Okay, 2. So that's the says which cell structures contain nucleic acids. So make sure you're solving this question, guys. Make sure you are doing this. All right, which of them contains nucleic acid? Cytoplasm, yes, cytoplasm contains, you can find transfer RNA there, you can find messenger RNA, okay, and then you can find ribosome RNA, because ribosome can contain it contains ribosome RNA. So this contains, lysosome doesn't have nucleic acid. Mitochondrion contains circular DNA, 70S ribosome, which contains, of course, ribosome RNA. Ribosome RNA is a nucleic acid. So there's nucleic acid here, okay, circular DNA, all right, and of course, ribosome RNA, all right. There's also nucleic acid here. So 1 and 3, do you get? So the answer is 1 and 3, which is Charlie. Charlie. All right. So we have mitochondria thought to have evolved from prokaryotic cells that they were ingested by ancestral cells. So this is the endosymbiont theory. Okay, mitochondria and prokaryotes, they were thought to be ancient prokaryotes that entered into a mutualistic relationship with prokaryotes. So if they are actually prokaryotes, they say which features have prokaryotes lost during their evolution into mitochondria. Okay, which one have they lost? Did they lose a cell wall or circular chromosome or endoplasmic reticulum? Now, pause this video and try it, okay? So, mitochondria, they don't have cell wall. Mitochondria, sorry, they don't have cell wall. So probably they must have lost it. They should have lost it. But let's go. They still have the circular DNA. They never have their endoplasmic reticulum, right? Because prokaryotes don't have membrane-bound organelles. Okay, they have the 70S ribosome. So this and this are still there. They never had this. Probably they lost their cell wall because prokaryotes have cell wall. So if mitochondria are thought to have evolved from prokaryotes, that means they lost this. Okay, they must have lost this. So the answer is A. Okay. So what do you think? All right, the answer is A. Let's go to the next question, please. Which polymers are present in all viruses, all prokaryotes, and all eukaryotes? Okay, so which ones are present? Try. Which ones are present? Which polymers are present in all viruses? So prokaryotes and eukaryotes, they should have everything. But we want to check the ones that are found in viruses. Okay, don't forget that viruses, they always have genetic material. The genetic material is inside their capsid protein coat. So polynucleotides, it should be there because capsid is a protein. Okay. No, it's polypeptide. Yeah, polypeptide should be there. Then polynucleotide should be there because they either have DNA or RNA. These two should be there. Polysaccharides. Not all viruses have polysaccharide, but all viruses have a nucleic acid, which is a polynucleotide, surrounded by a protein coat, which is polypeptides. Okay, so what do you think it should be? Should it be A, all of them, or 1 and 2, or 1 and 3? That's polynucleotide and polysaccharide, or 2 and 3. The answer is actually 1 and 2. Okay, all viruses have polynucleotides, okay, DNA or RNA, and they all have polypeptide capsid protein. Triggered. So let's go to the next question quickly. So how many of the listed structures typically contain genetic material that has telomeres? Okay. I'd like you to solve this. Is it bacterial cell, chloroplast, mitochondria, or nucleus? Before I bring out the options, so guys, how many? Now, bacterial cell, pause this video and try it as I work it out. Bacterial cells have circular DNA, but their DNA does not have histone protein. For it to have telomere is repetitive base sequence, okay, found at the tip of, for check. So let's do it. This is a chromosome. Remember, this is sister chromatid, okay, linked with another sister chromatid. Watch this. So this is chromosome. When cells start dividing at prophase, they appear like this. So at the tip of chromosomes, we have telomeres. So telomeres are repetitive base sequences found at the tip of chromosomes that prevent loss of genes. So if you check here, guys, telomeres are here and here, here. So at the tip, they prevent loss of genes or loss of genetic materials and ensure continuous replication. Okay. of DNA. Is that okay? So if you check that, so you see that it's found in chromosome. So bacterial cells have only DNA. Chromosome is DNA plus histone protein. So their DNA doesn't have histone protein. Chloroplasts have DNA, no histone protein. Mitochondrion has circular DNA, just like chloroplast, they have circular DNA. The three of them have circular DNA, but their circular DNA does not have histone proteins. So they are all right. But the nucleus has DNA associated with histone protein. Okay. So the nucleus, all right, is only one with chromosomes. That means it's only one with structure with that contains telomeres. So it's only one, okay, only nucleus. So let's look at um, the options. Okay. So which one is it? Is it A or B or C or D? So it's of course A. Only one of them. All right. Let's go to the next one. Now they said, look at the next question. Steps 1, 2, 3, and 4 are used to test for a non-reducing sugar. You can see that. So test for sucrose, test for non sugar. That's step 1. Put 5 cm cube of solution into a test tube. Yes. Add a few drops of acid. Yes. Neutralize with alkali. Yes. Add 6 cm cube of blended solution. Okay. When is solution heated or boiled? Okay, let's see. When is it heated or boiled? Pause this video and try the question. When is it heated or boiled? Right? When? Okay. So if you remember, when you put 5 cm cube of solution into a test tube, add a few drops of acid, then after 1 and 2, you hydrolyze. You boil so that sucrose can be broken down into glucose and fructose. Glycosidic bond is broken down. So you boil here. Then after you cool, and you add an alkali to neutralize it. And they add then the solution again. It should be the 5%, okay? And then you heat again. So now they said then there's a when is it supposed to be heated? You heat it after adding acid and then after adding the solution the second time. So between step 1 and 2, no, between steps 2 and 3, between. So which one do you think? Between steps 2 and 3 only. After step 4 only. So between steps 2 and 3, yes, between steps 2 and 3, yeah, here this way you heat it, okay, and then after step 4. So when you add the acid, all right, you have to boil, and then after neutralize, you add the section again, then you have to also boil. So the answer is supposed to be, all right, B. Good. Please don't forget that this is 13 Universal, and you are on with schedule, Caie biology. Okay, yeah, all topics. So let's go to this. Which features contribute to the function of a cellulose molecule? Which contribute to the function of a cellulose molecule? So let's check this. Is it long chains of glucose molecule called to helix, or many hydrogen bonds formed between adjacent chains? Okay, or is it is insoluble in water? So guys, I want you to pause this video and try to solve it. All right, so what is the answer? Cellulose is a structural polysaccharide, it's part of the cell wall of plants, so it helps to provide strength and support. Okay, now long chains of glucose molecules called to helix is not why it's able to provide support, but it has many hydrogen bonds. So we have many hydrogen bonds linking the cellulose molecules. All right, so cellulose molecules, remember that each molecule of cellulose consists of a chain of beta glucose molecules rotated at 180 degrees Celsius. All right, and then of course we have microfibrous cellulose molecules linked by hydrogen bonds. So hydrogen bonds here are playing a role. They act as cross links, and each fiber is formed by lots of fibrous linked by hydrogen bond. So hydrogen bond provides, all right, cross-links. So that's what gives it mechanical strength, high mechanical strength. Okay, and of course it is insoluble in water. So it's 2 and 3. What do you think? So 2 and 3 is C. Let's go to the next question. What correctly describes triglycerides? All right, what do you think is the answer? Pause the video. Triglycerides non-polar. Yes, they are non-polar molecules. Yeah, they are soluble in ethanol. This is correct. Now, then they are not polar molecules, so C and D eliminated. This is between A and B. All right. Yeah. So they are not polar. They are not soluble in water. So triglycerides are non-polar molecules that are soluble in ethanol. Okay. So the answer is A. So I want you to make a comment, share this video, talk to us. Okay. The last question for today: cocoa butter contains 3 different triglycerides. These triglycerides are made from the fatty acids. You can see that: oleic acid, palmitic acid, stearic acid S. So the three triglycerides found in cocoa butter are POS, SOS, POP. Alright, the chemical structures of the triglyceride POS is shown next to a diagrammatic representation of POS. So that's it, guys. So this is the one we have here. That means that P is this fatty acid, O is this fatty acid, S is this fatty acid. So when they say POS, because the first rule, you must understand the question. All right, you just keep interchanging them. All right. So the question now is, it says, let's look at the question. What does the question say? So which statement is correct? So which statement is correct? Okay. All right, that's it. We're gonna walk through it one by one. Okay. So which one is correct? A says triglyceride POP contains 2 unsaturated fatty acids joined by ester bonds to glycerol. POP contains 2 unsaturated. Now this is POP. Now that means it's gonna have P here. It's gonna have P instead of S. Okay. 2 unsaturated. Then you're gonna have POP. P is saturated. P is saturated. The same P is saturated. So POP means P is gonna be here. So P is here, saturated. This is saturated. It's only O that is unsaturated. So we cannot have 2 unsaturated in POP because P is saturated and this P is unsaturated. It's only O that is unsaturated. Look at it. How do we know? Yes, double bond. Double bond, presence of double bond means unsaturated. Single bonds all through means saturated. Okay, so P is saturated and we have 2 P's. We can have 2 unsaturated. All right. Okay, so A is wrong. B says triglyceride POS contains 2 less carbon atoms than triglyceride POP. POS contains 2 less. All right. Remember that if you check this, this has shorter carbon. P has shorter carbon compared to O and S. Okay. So this is already 2 less. Watch. This is 2 carbon less. And they say triglyceride POS contains 2 less carbon atoms than triglyceride POP. Now if you have POP here, POP means that here is P, here is P. So we're going to have 4 carbon atoms less in POP. Okay? And POS will have more carbon atoms than POP. Okay? Why? P here is 2 carbon short. Alright? Okay? If you put another P here, it will be 2 extra carbon short. If you count these carbons, look at it, count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15, 16. Now if you count this one, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is 18. And if you count this is also 18. So this is already 2 carbon less. If you remove S here and put P, that means it will be 4 carbon atom less. So POS, okay, will not contain less carbon. It will have more carbon atom than POP. Okay. Yes, because here will be less. here will be less. If you do POP, P will be here, which is 2 carbon less according to this, right? So this statement is wrong. POS can never be 2 carbon less. It is POP. All right, that be 4 carbon less. Is that okay? All right, because we're having 2 P's. So P is 2 carbon less. So if you have the first P 2 carbon, second P 2 less. All right, if you go to C, triglycerides, SOS contains 4 carbon atoms. Okay, 4 more carbon atoms than triglyceride, POP. Yes, SOS means this is S is going to be here, which is 18. Okay, 18, 18. If this is S, that means 18, 18, 18. All right, but if you're doing POP, POP will be 16, 18, 16. Do you get? So 16 here, 16 here. That's 2 carbon. That's 2 carbon less here, 2 carbon, making it 4. If you're dealing with POP. But SOS, okay, we're gonna have 18, 18, 18. POP 18, no 16, 18, and then 16, which is P. So this is correct. D, triglycerides, SOS contains 2 saturated fatty acids joined by hydrolysis. Okay, SOS, S is saturated, O is unsaturated. Okay, they said SOS contains 2 saturated fatty acids joined by hydrolysis to glycerol. There's no bond called hydrolysis. It's just a bond. Okay, so the answer is C. All right. So pause the video, watch it again. This is where we stop for this our topic. All right. So the answer is C. So thank you. Leave your questions. Follow us. Share the videos.